We have many earthquakes in the Reykjanestá. That is the tip of the Reykjanes Peninsula of Iceland. The earthquakes started today, and they're concentrated and clustered there, almost short of being a swarm. Look at the size of the earthquakes and the concentration. Many of them also are happening probably at near the shore in the ocean, Atlantic Ocean. And this is the latest distribution of them, time distribution. The biggest one was around short of the 2.6, 2.7, and they're all happening along the boundary between the Eurasia and the North American plates. At the moment, we don't have any eruption, unlike what we saw in the, for example, Reykjanesá, that we have a cluster of the earthquakes. But nothing in theory can stop it to have an eruption in the ocean. However, we will not see it. This is happening in the deep waters. What we can see is that they release the fault lines engaged in one point and transfer the movement to the next, which will be the L dwarf and the Svartsengi volcanic systems. I have a video about this previously made in a similar situation before a recent eruption in the Svartsengi. Please watch that. A cluster of the earthquakes has started in the Reykjanestá. That is the end point of the Reykjanes Peninsula, a peninsula in the Iceland which extends from the west to the east. And when we have the earthquakes in one location along that, usually it transfers through a series of strike-slip faults toward the east. We are lucky that the Reykjanes Peninsula is in that direction, longitudinal. That makes it very easy structurally to see how the earthquakes are transferred. This is a peninsula, as I mentioned. It has geothermal activity there. We have a geothermal power plant there. And past eruptions also have happened there, like many parts in the Iceland. Is Iceland created by these activities? When modern earthquakes happens in one location in the west, it gradually, through these transform faults and volcanic system, transfers toward the east. These are the strike-slip faults that practically we discovered the plate tectonics by studying them on the ocean floor by the magnetic stripes that we could see actually on our charts. And this has created these volcanic systems, we call them. They are kind of body-nature landscape of fault lines and rift valleys in the Iceland. And usually they start in the Reykjanes Ridge in the Atlantic Ocean. Then they move through this transfer of the strike-slip fault movements to accommodate the movement toward the Reykjanes Peninsula. This is where the earth crust is splitting. Atlantic Ocean was created in this way. And the roots of this is deeper in the mantle of the earth, where we have the uplift and convection of the heated material coming to the surface. North American plate and Eurasian plate practically are separated through this uplift of the material, through this extension of the oceanic crust, where everywhere else Gondwana was joining together. There we are a splitting of the earth, and these are rooted deep in the core mantle boundary of the earth. We may have eventually an eruption, but not directly at this moment. But through this strike-slip fault lines, we have these volcanic systems, including the Svartsengi volcanic system, which is active at the moment, and we are expecting any moment an eruption there. It may eventually lead also to eruption in the Svartsengi volcanic system. We have to wait and see.